Hi, and welcome back to the Applied Innovation Exchange in San Francisco and another live episode of The Makers. This is where we meet and learn about the stories and the new companies, the entrepreneurs in the AI space. And we follow the arc of the origin and the making of the company and the traction and what's ahead of them. And today, I am super excited to have with me the co-founders, the CEO and co-founder Tara Khani, and a little bit later in this episode, we'll also be joined by Majid Fekri, the co-founder and CTO of Moorcheh.ai. And before we get into the conversation with these two amazing founders and Moorcheh.ai, I want to encourage all of you viewing and participating in this LinkedIn Live that you have the opportunity to post your own comments and questions, and we'll field them as we go in the conversation and keep it very conversational. So feel free to drop your questions and comments in the LinkedIn live comments here, and Brian, who is behind the scenes here, will pick them up and we'll go into that. But welcome, Tara. I'm so excited to have you and Majid here. But tell me about Moorcheh.ai. Tell me in one sentence, what is it?
Okay. Thank you so much, Andreas, for having us here. It's really hard to say it in one sentence, but I'll try my best. So Moorcheh.ai is an infrastructure as a code, an agentic memory that can scale to trillions of workload with higher accuracy, sub-millisecond latency, and no ideal time.
Wow, you did it in one sentence. Great. Okay. So if you expand it on it a little bit more, so tell us about the company and the core problem you're attacking.
Yeah, absolutely. So this really, so Majid and I, we both co-founders. We um, we we were working together at Sodi, mobile device management company, and we had this vision that it was 2024 that AI is going to change, revolutionize the industries. So we left the company and we did some consulting projects, and we built some AI companions for legal companies, legal SaaS companies, and we figure that these databases is not scalable. They're not built for scalability. So the more data you feed to these knowledge management, it's really become out of control. The RAM usage and then accuracy becomes another bottleneck. So that was the core bottleneck that we focused on building Moorcheh. I can elaborate on that. I'll
Yeah,
stop
no,
right there.
yeah, exactly. No, that sounds great. So, of course, this episode and this conversation with you and Majid, I feel we're going to have a broad lens, and the lens will kind of start from the left from a business perspective, especially nowadays when we talk about AI agents and agentic AI that seem to, of course, increase in popularity and focus, but they're super hard to actually get into production and get working. And there are some business implications for that. And then on the other side, Moorcheh is attacking the AI stack with some very novel approaches. And this episode will also go into the deeper tech perspectives on that. So I appreciate you actually, covering a lot of space and domain here. Let's look at agentic AI
Right.
and enterprises now moving from pilots and prototypes into production, and are still struggling and facing concerns. So what are some of the main concerns that you have found that they are struggling with?
Yes. So when it comes to agentic AI, it's like big enterprises, they hit the RAM wall, right? So there is this huge context. So this is not the passive way of looking things. So you're looking at everything in an interactive way. So I give you an example. I was talking to one of my friends, a lawyer, who was building this SaaS legal tech company with some other co-founders. And he put it well that, we need agents that are very interactive
Mm.
and they are deterministic. They know what they're doing,
Mm.
and they make a discovery call, conversation with the client,
Mm.
and they do a lot of reasoning,
Mm.
and then they close the dialogue.
Right.
So that needs a lot of memory, and a lot of, in the back end, it requires a lot of RAM
Mm.
to make sure that all of these reasoning and all of these context
Yeah.
is somewhere. Otherwise, there's going to be too much back and forth with LLM, right? And a lot of
Right.
tokens burned on something that it's going to be forgotten
Mm.
because of the non-deterministic
I understand.
status.
Yeah. So it uh, it resonates with all of us who have been building agentic solutions for a while, that we end up working a lot on the memory side and the context aspect of agentic AI,
Mm-hmm.
providing a continuous context to agents so they can operate, reason, take actions that
Mm-hmm.
are relevant.
Right.
So uh, the approaches that we typically take today, it's difficult in an AI stack to avoid vector search and RAG pipelines. So what's your take on that, and what kind of challenges have you seen in that space? And Moorcheh is kind of coming into that space with some novel new ideas.
Absolutely. So we see definitely that the problem that existed in vector search and in RAG
Mm.
now is pulled into agentic
Right.
ecosystem,
Mm.
right? Because that was never solved.
Yeah.
So that the RAM heavy, the problem that, like burning cloud to make sure that all of this data and dependency, the proprietary data of the company is the core of information,
Yeah.
not the LLM,
Mm.
is still, that has moved to the agentic workflow,
Mm.
right? So we see that with the agentic workflow, to make it really like all of these contexts,
Mm.
to make sure that our agent is doing its work really well, and it's not like after few statement
Mm.
talking to the client, is
Mm.
not forgetting what happened few statements before.
Mm.
Again, we come back to the same problem that existed within vector search,
Mm.
semantic search,
Mm.
because now LLMs are now more commoditized,
Mm.
right? Like everyone, it's all about pricing, and everyone is using it, right? It's the competitiveness is not as much as it was a few years ago. So,
Mm.
so it become more about retrieval, right? So who can make a better retrieval? How these agents can better act, how they can reason, how they can remember, it becomes the competition edge when it comes to agentic workflow. But because that, hasn't been solved in the
Right.
RAG,
Yeah.
now we are kind of moving it to this agentic workflow.
Mm. All right. So we are going to take a step down into the AI stack, and we're going
Mm-hmm.
to go into the deep roots of Moorcheh from a technical perspective. But before we do that,
Mm-hmm.
let's look at the company for a little bit, right? I think the history of Moorcheh.ai and Edge AI Innovations, right?
Mm-hmm.
The origin. Can you just tell us where you are today, how it started? And I understand you and the co-founder Majid, you go way back. So,
Yes.
so tell me a little bit about that.
Absolutely, yeah. So both of us, we did our engineering together undergrad,
Mm?
and we are coming from a like mathematics background. We always look at things like fundamentally, like that kind of mindset. But again, like Majid did like more of a PhD and science, and I was more of application and engineering.
Mm.
And I moved from engineering to all the way to product management to sales, and I
Mm.
was obsessed with customer feedback and how we can get that and bring it back to the product management. But going back, how Moorcheh was kind of the conception. So when we both worked at Sodi, the last job we worked together, um, we knew that in this era of like we are living in a 2 years ago in a very specific, like really, really important time, right? Things are going to change with AI. So we knew that. And Majid had this vision that every like AI has to kind of compress the RAM heaviness has to change so it can make it ready to be applicable on edge devices. So when we quit, we called our company Edge AI Innovations, but we didn't know what we're going to solve. We just had this vision. And we started doing some consulting projects, built some AI companions, and we saw a bigger problem there. And we thought if this is not resolved, there's no going on the edge because edge requires efficiency. And we are not efficient enough on the knowledge management when it comes. So, for example, I give you an example. When we built this project for a customer, again, we were working with so many clients, like legal data, insurance data, so many like different PDFs, OCRs, audio, video, and we had to choose between the vector databases, and we were charged without knowing. So there was no there was no time that this was like stop working.
Yeah.
It was always there, no matter the query was going or not. So we thought that's number one, why it's this way.
Yeah.
And because we are at the beginning of the whole revolution, we should look at like a scientist, look at that, not as an database engineer.
Right.
Because, you know, at the core of things, if you look at the technology, at the core, like physics, mathematics, chemistry, they're really the same, right? If you look at the bottom of it. And if you look at like 10 years from now, 5 years from now, things gonna change so much. So we had that vision that this is not going to be the same. The way that this burning, you know, RAM, it cannot be sustainable and it cannot be the same. So we kind of focus on that bottleneck. And we built the MVP last January. But then my instinct was like, okay, we can't just build. We need to put it in front of users. So we made a trip last January, came to Silicon Valley, talked to almost 500 AI engineers, CTOs. Well, like, guys, this is what we are feeling. This RAG is not, there's no accuracy. There's so much reindexing with vector searches. These are fundamentally doesn't feel right.
Right.
And they actually correlated, those data correlated with what we thought and what we built as an MVP. Everyone was complaining. They started hating RAG. They're like, this RAG doesn't work. You know, like, why do you need to, I add this re-ranker to this vector search because there's no accuracy.
Right.
Right. And that's like GPU heavy.
Right.
And then my vector search is CPU heavy. And I have to spend hours on reindexing while things are down. So we saw that like this is not just like our problem. This is like these 500 AI engineers, CTOs, head of AI's problem as well. So we kept talking to these guys. And what do you want to see in a dream world, right? And we kept adding features to Moorcheh. And in September, we launched it as a whole vector search, that was accurate and bring down the latency, so sub-millisecond.
Yeah.
So that's the story up until then, before we acquired like customers and, you know, talk to the one level further than the users, just mostly like enterprise customers.
Yep. All right. Before we let Majid in, I can't help but notice your lovely T-shirt, right? And there's an ant on the T-shirt, right? What's the story about the ant and the connection to the company?
Absolutely. Yeah. Thanks for asking that, for noticing that. So Moorcheh means ant in Persian language. So we are kind of obsessed with ants because we think that ants are tiny and their colony is scalable no matter what, and they don't forget their path. So there's this, like goldfish memory.
Yeah.
And on the other side, the ants are, they know what they're doing. So like pretty much similar to agents. I know it's kind of a funny story of the company, but like what we have built on top of Moorcheh in agentic era, which is a memory, we called it MemAnto, so memory of an ant.
Of course.
inspired by the movie Memento.
Of course. Yeah. Well, that's a great story. Thanks for sharing that, Tara, and thanks for setting the stage about the company and conceptually what you're attacking. I think it's super exciting and resonates with many of us who are kind of building agentic systems today. So we're going to switch over now in the studio, and we're going to hand over the chair and the microphone to your co-founder, Majid. Thank you for joining today, Tara.
Thank you so
Appreciate
much,
it.
Andreas,
Thank
for
you.
having me.
All right. So while we're switching up here in the studio, I'm going to again encourage all of you to post your questions and comments in the comment section here on LinkedIn, and we'll have Majid.
Hi, Andreas.
Hey, get the mic all set up,
Yes.
and we're looking all good.
I'm set up.
Yeah, fantastic.
Thank you so much for having us.
Thanks for coming. You know,
Pleasure.
let's. I want to dive straight into this thing, right? Of AI agents, agentic AI, and the problem of keeping them contextualized, relevant, context in context. And there is in multi-agent systems today, the way we think about them being more and more part of these rapidly evolving workflows and processes, and some even think about agents as team members in the team. So it's a rapidly changing data and context setting. So providing relevant context, almost I would say in real time, to agents, that's a real challenge, and you're attacking that. Can you tell me or tell us about that?
Yeah. Just to reiterate, this is the most important question because models are becoming more intelligent, more capable.
Mhm.
Agents are having access to more tools. Um, and what comes to us is the onus is on us to provide the most accurate context for every given task,
Yes.
to specify it. And now every word you use matters
Yes.
because your agents are going to act on it and
Right.
it's going to have consequences.
Yeah.
For you. So it's everyone's problem. Now, but our engagement came a few years back
Mm.
when we were, as Tara said, we were working on the RAG pipeline.
Mm.
And the fundamental difference was that RAG was supposed to be a static corpus of data.
Right.
It's just a bunch of documents that's sitting there.
Mm.
And the only thing is you're querying them many times. And there will be some user that is asking question and we use AI to answer those questions.
Right.
That was a much simpler times
Mhm.
and
Yeah,
easier
yeah.
problem to handle.
Yeah.
But now that we're moving to agents, everything is a lot more faster
Mm.
and more dynamic.
Right. So RAG doesn't really work for that
Right.
fast changing memorization, right?
Exactly. And it's not, when we say fast, it's not just the retrieval time.
Right.
It is you're reading, writing,
Exactly.
deleting
Yeah.
part of your course, and you have to keep it dynamic.
Yeah.
And by design, some of the architectures
Mm.
that traditional vector databases use is that if you change more than 10% of what you have in your database, you have to reindex the whole thing.
Yes.
Otherwise, you're going to lose massive accuracy.
Yes. Right. So in preparing for this episode, so I know you're making some very bold claims in two papers, and I will actually encourage all of you who see this to go download these papers. One is, I'm just paraphrasing the title, Rethinking Semantic Search with Information-Theoretic Retrieval. That's a 2025 paper, end of. And then this year you published a MemAnto, a memory system for autonomous AI agents.
Mm-hmm.
And it's a thorough review, and I would say a drastic I would say drastic destruction almost of the current stack. You're arguing that the current vector search stack and how we think about memory for AI systems may be fundamentally flawed. That's kind of and then you are suggesting another architecture.
Yeah.
So can you walk through just briefly what you are replacing with what?
Mm. So, yeah, instead of being a destruction of what's existing, this is more invitation to rethink some of
Mm.
the fundamentals,
Yeah.
because this is how technology evolves. You have a period of innovation,
Mm.
and then they become commoditized and solidified, and you go to the next step, and so on, and they bury deeper into the stack. And I think we moved too early with some of the semantic search capabilities,
Mm.
because this was supposed to be the most amazing kind of search. You, for the first time, you can search the meaning of things
Right.
and
Mm.
concepts, not just keywords.
Right.
And we move too fast with it because I think there's so much potential here. Um, now, the first paper, we're saying that let's look at the whole RAG or context at a holistic approach.
Mm.
Um, we are dividing it into many different individual components.
Yes.
But if let's look at the end-to-end accuracy, and the argument in brief is that there are three main formulas in the stack. One of them is like using float point calculations with the HNSW tree structure. And I'm now getting into it
We're
more
going to go
technical.
deep, yeah.
Okay,
So
yes.
I already warned the
Just to
viewers.
warn.
Let's go deep. Yeah,
Yeah.
let's stay there. Yeah.
Basically, HNSW is an amazing
Mm.
algorithm that allows you to create tree structures
Yeah.
of your existing nodes and then make it much faster, makes it log n order magnitude when you do the search. And then you use cosine similarity for training your embeddings and also for retrieval. And yeah, and that's what you get is a cosine number similarity. But what I'm suggesting is to replace it with another approach. Let's first make compressions, because if you have just a bunch of text that is
Mm.
maybe 1 kilobyte or less, and you turn it into multiple vectors that each is 1,000 float numbers, we're exploding the amount of
Right.
data.
Yeah.
And we don't want to explode the entire internet and make 25x or 50x bigger.
Right.
Right? So we have to start with compression. Now, there are many ways to do the compression. There's infinite ways. Anyone can come up with their own. We decided to go with the fundamental Shannon's theory of information. I want to know what's my channel limit, and I want to know what's the entropy measure. And once I go to binary, now dealing with binary is much easier. I can do full scan. Um, Even though it's linear scaling, at some point I'm still better than the HNSW at a certain range, and I can take that. And it makes it efficient distance metric, what we call the second stack. So the first stack would be binarization method. The second one is the fast calculation, and we optimize it for CPU architecture with
Mm.
pop count, which is very convenient. And the third one, which is almost same importance, is bringing back the loss of information through information-theoretic score, which goes back to my PhD research. I invented this score, but it's mutual information, basically looking at vectors not as vectors, but looking at random signals
Mm.
and measuring that. So these three together build a whole stack that replaces HNSW and cosine similarity.
And what would you say if you compare two different stacks? The current one we find in most enterprises today, building agentic systems, basically building on traditional RAG pipelines and such, and then we replace those components with Moorcheh.ai
Yeah.
technology. What are some improvements, performance improvements, and maybe accuracy improvements as well? Because
Yes.
we need to talk about that as well, right? We have
Absolutely.
some accuracy improvements with your approach,
Mhm.
almost to the extent that we can talk about deterministic behavior in
Yes.
agents using Moorcheh.ai. Can you talk through some of the improvements? What are the highlights in terms of improvements that we're
Yes.
seeing?
So originally we were Edge AI Innovations, so we designed this method to be running on restricted resources.
Mm.
And once we did that, I found that I can run it on a Lambda function, on a tiny cloud function, with limited RAM and 2 virtual CPUs, they can do the entire retrieval part. And this opened up the whole architecture on cloud, which is native serverless. And then you, as the Moorcheh idea came, you can have many, many concurrent workers doing the retrieval
Right.
and going back to
Mm.
zero.
Mm.
And that's what Moorcheh architecture
Mm.
opens up. So you can have many interactive agents doing lots of queries at every time, reading, writing, asking questions. That opens up this dynamic behavior. Also, on the database side, we don't need to index and reindex
Right.
because those binaries work as index.
Mm.
So immediately, as soon as you put something in, is available for query, and as you remove it, it's gone and doesn't need to reindex your.
So are we? So we're saving on compute. We're saving on storage.
Yeah.
We're saving on performance, or not
Mhm.
saving, but we're seeing improved.
Yeah.
Do you have some metrics
Yeah.
there?
Yeah. So the metrics are in the paper. So we use the MARE benchmarks,
Hmm?
massive AI retrieval benchmark, but we also looked at end-to-end quality of the RAG. And what helped with the end-to-end quality of RAG, I think, was the information-theoretic score
Mm.
that works as a re-ranker. So
Mm.
everything you submit to Moorcheh is
Mm.
ranked
Mm.
by the score.
Mm.
And why it helped, I think it helps AI ground every piece of information by its relative relevance.
Yeah.
And it's a number normalized across embedding systems, uh, which you don't get with the cosine similar. There's an effort to make it universal score, but ITS does that. So it tells you where to cut off irrelevant context, and that helps ground answers a lot more and increases the quality.
Mm. I understand that. I turn to the audience actually for a second, Brian. If there are any comments already that we could take, I'm happy to take them. Otherwise, I'm encouraging the team to, or the team, the viewers, to post questions. You have something there. Great insights. Really impressive work.
Thank you.
Wishing you a lot of success. Okay, that's great. Thank you.
Thank you very
Very nice.
much.
So, reminding you, this is a great opportunity to ask questions with to Tara and to Majid. Let's go back to the uh, one of the reasons why AI agent or agentic AI fails. Let's go up conceptually speaking. Would you agree that the in the nature of AI agents being non-deterministic to some extent is their strength, right? That you have the ability to have open-ended conversations or questions or situations where agents step in and reason and think using both model capabilities but also proprietary data and documents to kind of ground the reasoning. But there is also, to some extent, a problem with the non-deterministic characteristics of AI agents that Moorcheh is addressing. What are some of the key problems that you have found in non-determinism in agentic AI that Moorcheh now addresses?
Yeah, it is a major engineering problem for everyone who's dealing with agents. You usually have these internal loops for finishing tasks, and it can go wrong in many ways because of non-deterministic nature, which makes it difficult to log the errors, failures. It makes it difficult to run the test algorithms properly. So now we didn't completely solve that problem, but I was just saying that at least when the AI is asking for context, it should be a deterministic answer, meaning that if it asks it now and it asks later, I should get the same answer as much as possible. So at least that part, the grounding part of the AI agents, should be a solid ground that they can stand on. We cannot change the nature of agents themselves,
Right.
but we can give them a solid answer. And that's what full scan idea comes in. We're not doing approximate nearest neighbor. We would just if AI is looking for a needle in the haystack, we need to find that needle and give it.
Mm.
Um, so that's what the pressure to do the full scan
Mm.
came from. And it's you ask it now, and if you ask again, you get the same exact, not only the answers but the scores. All this remains.
Yeah. So in today's stack, we are typically obviously separating the retrieval from the re-ranking. And why is that the wrong abstraction?
Yeah. First of all, it adds a big overhead. So everyone is just fighting for the milliseconds improvement on the
Mm.
database side, and then you go to re-rank and it takes 2 seconds, 2.5 seconds, or
Yeah,
it
right.
fluctuates
Mm.
because
Mm.
there is a whole um, architecture of neural networks running
Mm.
behind the scenes, um, and also it's a lot of expense added. And for production, you definitely need re-ranker accuracy. So Moorcheh, with having this ITS, resolves some of that problem. You can rely on it as a production quality, already removing the tail that is irrelevant and grounding your AI. So that's a
Mm.
benefit.
Mm. So I want to go back to something you said, and I think Tar also alluded to in the beginning. Um, the origin of Moorcheh from a technological perspective, or yeah, from a technological perspective. Uh, f- Found it interesting to hear that you started the problem statement analysis in an edge AI context, and in that context, the way I interpret it is it's a context where you are severely limited in compute capability, storage capability. We're often talking about small devices that may
Mhm.
not actually be connected to anything, it just runs locally. So you're constrained. And now, how do we apply and build AI solutions on a small device that just runs on the edge? And you started there, and you found this approach um, to 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 solve the problems algorithmically, I would say, um, and then you concluded that if we do this on the edge, what if we bring it into the back end,
Mhm.
where we have like the luxury, if you would like to scale both horizontally and vertically, and we can live with poorly designed architecture? But what if we actually fix some of these main problems also on the back end, and we can realize like materially tangible gains from a performance, compute, cost, accuracy
Yeah.
perspective? I found that 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 trajectory from edge into back end interesting. Can you elaborate a little bit
Yes,
about that?
I would say we are from edge, and we will go back to the edge.
Mm. Mm.
Because I think at the time, like say 2 years ago, all the frontier models were on the cloud or as a SaaS approachable, and the models that were only for edge were limited. But I think the technology is going there. The models are becoming, even the frontier quality models are becoming open source, available,
Mm.
quantized,
Mm.
ready to run on small devices.
Mm.
And also the technology is improving. You have now tiny devices that are a lot more capable
Yeah.
of running things locally. So 30, 40, 60 flops compared with the amazing resources on the edge. So I think that's coming, and
Mm.
we're headed for that. We will go back to the edge and having the full intelligence or agents running on edge. But at the moment, um, when we built it, we found that wow, this opens up the whole door for optimization on the cloud architectures. So that's where Moorcheh was exploring at
Mm.
the time, and I think it's valuable for anyone who's building cloud
Yeah.
infrastructures for RAG or
Yeah.
knowledge. So
I agree. I have two follow-up questions to this,
mhm.
or reflections. One is actually, I'm going to start with uh, th- are there any analogies from
Mhm.
the industry, the similarity being um, discovering or designing technology for edge purposes, and then that technology finds its way into back-end infrastructure and architecture. Have you seen that before in the industry?
Yeah, I actually thought about it. I can think of one example in hardware industry. Like if you look at ARM architecture, started as for tiny devices and very restricted computation, and now it's accessible on the cloud, and it's actually one of the preferred architectures on
Exactly.
cloud. And there are others, maybe incumbents coming in.
Yeah.
Yeah, so there's a lot of examples on the hardware and software, maybe, but I don't know.
Right.
much
No, but I think
on
that's a great example. So Moorcheh is conceived conceptually and maybe architecturally first on the edge, but now actually is incredibly relevant in the back end as we now have to address some of these major bottlenecks or challenges on agentic AI systems. So that makes sense. The other reflection on what you said, OpenClaw, as an example of a framework um, enabling fully autonomous AI agents running locally on
Yes.
oftentimes a Mac Mini. I heard Apple sold out on Mac Minis because OpenClaw became so popular.
Yes.
So people are running their autonomous agents on edge devices. Perhaps wouldn't call Mac Mini an edge device, but it's at least not an NVIDIA H100 data center. Um, would you see one trajectory for Moorcheh find its way into these frameworks that are intended to run on smaller devices locally as autonomous agents in this context? Is there an OpenClaw Moorcheh marriage somewhere?
Yes. We actually, as I said, I love the OpenClaw architecture, and we studied it actually, and we have a couple of videos going deep into how it works, how its memory is working, and so on. And when we were working on MemAnto, which is the agentic memory, it's open source, it's on-prem, you can host it anywhere you want, and we also have a MemAnto claw, which we married the MemAnto capabilities with OpenClaw natively, which means that you only need Moorcheh API key to run the whole thing. So if you own the architecture behind the Moorcheh, now you have completely isolated OpenClaw, a NemoClaw, basically.
Right.
And it gives you full security on an enterprise scale. So you own the backend virtual private cloud, and all the access to AI is through your channel. So I think
that's exciting.
yes.
Yeah. So why don't we switch over? I know you brought your laptop.
Yes.
And maybe you want to share something and show us, walk through something, where to get started or where to learn more and that kind of thing.
Yes. I'd like to show you our newest project. It is so new that we are still working on it. So we just made it open, and this is our launching day. So we are launching it officially.
We're launching it now officially
right now,
on the
officially.
Makers. That's fantastic.
First, before anything, I just want to give a shout out to our team, Neil, Head, Rasa, and Moin. They did a fantastic job. Just want to give them appreciation. Now, this is an open source project, so anyone is welcome to join and help us to improve it. And we call it Memory That AI Agents Love.
Love it.
And the reason behind it is in our second paper, we explained it. We said that we are building this for AI agents, and we had deep conversation with Cloud Code and other agents, and we tell them, what do you need for your memory? So we interviewed AI agents to see what they want for their memory. And we came up with this 6 design principles. For example, one of the most interesting things was that they said we just don't want a dump of memories. We want this to be intelligent answers. And another thing was this should be a good structure to the memories
Mm.
and so on. So I also show you the landing page because there's some explanations. Oh, by the way, we did benchmarks, long mem eval and
Yeah.
latency, and because we are building it on top of Moorcheh, we easily hit the accuracy on the benchmarks
Right.
because we rely on the semantic method
Right.
that we trust
Yeah.
ourselves. So it's really easy. Now it's available through PyPI pipeline.
Mm.
So you just say pip install MemAnto, and you connect it natively to your um, uh, agents
Mm.
on your own computer, and it becomes a co-agent. So it becomes a memory agent that joins your agent and help it keep a very long, almost unlimited context of work. This is designed for long horizon of work for days, months, and it will remember everything without problem. And this is what we have. Is MemAnto has a remember, recall, and answer endpoints.
Mm.
And remember and recall is basically putting memory into backend and remembering it,
Mm.
bring it back.
Mm.
But answer is unique to MemAnto. It's not just the dump of the memories. It is an actual agentic intelligence crafted by another AI on the Moorcheh side that gives the accurate, like the grounded answer,
Mm.
right? And this is how it works in a nutshell. We have um, AI agents connecting to MemAnto natively on your computer, and it connects to Moorcheh as a backend engine, and then whenever needed, it connects back. And then we explain how we identify this gap. I don't worry with this, but there are these. We define these 6 new principles of what are the gaps,
Mm.
and we are actually going to create our own benchmarks based on these, like new set of benchmarks.
Before you continue,
Yes.
Brian, is there any concern? Do you have a concern? Is there everything working on the back end? Yeah. It's fine. All right. I just want to make sure that everything is fine. All right. Okay. Sorry about. Okay. All right. All good. No. No. All good. Yeah.
All
go
good?
ahead. All right.
Yeah, yeah.
Sorry for that. All right.
Yeah.
Go ahead.
So yeah, we'll be talking more about the features that MemAnto has.
Mm.
It also features a full dashboard. This is also local on your
Yeah.
own terminal, which gives you a summary of everything's happened. You can test the memories, and you can explore all the memories. Everything comes with predefined types.
So before we continue, you have MemAnto as a framework that runs on top of Moorcheh,
Yes.
right? And what's the if you zoom out,
Mhm.
I am now an agentic AI system builder. So
Right.
I'm architecting a solution for my company that enables AI agents to do this or that.
Mhm.
What should my stack look like if you were
Mhm.
to combine MemAnto with Moorcheh?
Right.
How should I position these pieces when I plan it?
Great question. So as an enterprise, you just need to define your own private cloud, and Moorcheh deploys as a infrastructure as code, as a template.
Mm.
So it takes only 10 minutes to deploy Moorcheh on your backend. You own the entire architecture, and
Yep.
it's fully hermetically sealed, closed environment. Um, and you get the endpoints for API communication, and you also get monitoring dashboard with full logs of everything's happening.
Mm.
And then you can manage your API keys
Mm.
and access management. And you, for your employees, you can give them access to the API gateway and your own private endpoint. And then they can, for which with every key, they can run many agents. Like one instance of Moorcheh is enough for thousands of employees, and then each employee can run multiple agents with same MemAnto instance.
Mm. So I have MemAnto and Moorcheh. Again,
Mhm.
can you just stack them from an architecture perspective?
Mhm.
So
So
MemAnto's.
Moorcheh,
Go ahead.
Moorcheh resides on the cloud.
Yep.
But we also have the Moorcheh on-prem
Right. I
underlying.
understand. Yeah.
Yes.
Mm.
Uh, But for the enterprise, for large scale,
Right.
you have one instance of Moorcheh in
Mm.
your region that you want.
Yeah.
And then every computer or every person who's managing agents
Yes.
would have one instance of MemAnto
I understand.
running.
Right.
And the MemAnto connects to Moorcheh through that API key.
Right.
And that's all you have to set up.
Fantastic.
And it's, yeah.
Sounds almost like a colony of ants.
Connecting to the queen.
Exactly. Connecting to the queen.
The hive.
That's
Yeah.
fantastic. All right.
Yeah.
So I didn't want to interrupt you too much there, and do you want to walk through and
No,
show us
I just
more?
don't want to take much time.
Yeah.
I just walk through the few features that are unique to MemAnto.
Mm.
One thing that feedback that we got from AI is that I don't like conflicts in my memory. Okay, so Moorcheh, the MemAnto has this built-in capability that if you say something and a few days later you change your mind as a fact and or a preference, it would detect it and it would bring to your attention that, hey, there is this conflict.
Mm.
You told me that you prefer this database. Now you're saying another database. Which one is this?
Yeah.
And once you resolve it, it would keep a clean, non-conflicting memory,
Mm.
even deleting the one that is not fitting anymore. And we did a lot of, the expression is dog fooding. We used MemAnto for our own procedure. And one of the things that was my own pain point was that I start a project.
Yeah.
I change my mind. Okay, I go from version 1 to version 2.
Right.
I need the agent to change so many things for me.
Mm.
If I rely on local empty files, they get messed up very quick.
Yeah.
But with Moorcheh, I can do it and I resolve all the conflicts. So the context is clean now. It's understand that we move to version 2 and these are the changes.
I understand.
Right.
Very powerful. I mean, it sounds like it's likely not as you said before. It's not a destruction. It's not a full replacement. But this is an incredibly relevant complement into the AI stack, where especially in the context of again AI agents dynamically needing fresh data from the context that's ever changing, and this is where MemAnto and Moorcheh really shine.
Yeah. And yeah, I would just finish it by saying that it's natively connects to all these AI agents, Cloud Code, Codex, Cursor, Windsurf, and so on. Actually, we like open code, and we have plans to, because open code basically compresses your window as you move on, and it makes sense to pair it with a good memory workflow.
Yeah.
The other thing is we are integrated, like Moorcheh is already integrated into the workflow of Llama Index and LangChain and NA10, and now we are working on to bring it to Crew AI.
Yeah.
And also Crew AI is another place that we're really interested to enable, like have MemAnto as another tool
Exactly
in their toolbox.
So this is a good opportunity now if you keep this screen here, because we have stay there
Yes.
there with Crew
Yes.
and Llama Index and with Moorcheh, because tonight at 5 p.m. in San Francisco, if you're in San Francisco, this is a great opportunity to come to Capgemini on 1011 3rd Street at the Applied Innovation Exchange, and we are hosting an event where you will speak and present, and also the founder and CEO of Crew AI, Joe Mura, will present, and also Jerry Liu, this co-founder and CEO of Llama Index. So we're bringing the teams together to really talk about the opportunities of agentic AI, but also how to solve some of these pressing challenges. And I'm looking forward to having more to learn tonight from you and from Crew and Llama Index. So that's tonight. So what final things you would like to share before?
Thank you very much for having us. We're really grateful and happy to be here, and I'm looking forward to the next project. And we also have the MemAnto Claw releasing soon, so we keep
you keep working
building
this, and reach so to the audience, then are there any questions, or I see some shout outs, that's great, but are there any questions you would like to highlight, or otherwise, Brian? No, not really.
There are so many congratulations and great questions
Yeah.
coming from the audience.
All right. Okay. Perfect. Well, they are all visible for everyone to see those, and after the live event here, Majid and Tara, you can engage with the people, the the participants on the questions, and also it's a good opportunity to say that if you want to reach out to Majid and Tara, this comments field is obviously one way to do it, and they will follow up. Also, tonight is a good opportunity to engage in person if you are around. Um, Final reflections. If you and this is where I would love to have both of you here, actually. So, if you want to say anything additionally here, Tara, we're just going to do a quick switch as well. But if you look ahead now, we're 2026 and the coming couple of years, from a both a Moorcheh perspective, but also from an agentic AI perspective, generally speaking, where do you think we're heading with all of this, and how can we help enterprises make sense of what's happening?
Yeah. One big shift that comes to my mind is that we're going to build tools now for AI agents. They becoming a new customers. So it's the same way that you interview a customer to know what their needs are. We did this experiment with MemAnto, and we hope this is actually AI agents. We're gonna love it, but we should do more of that, like bringing in AI into the design and production of new products
Right.
that are invention by the AI. So I think that's gonna happen a lot more.
Yeah.
And that might mean that some of our infrastructure stacks would be redesigned as well, which would be major work for a lot of enterprises.
Yeah. This is like super exciting, and I am very grateful, feel privileged to having had this conversation with the co-founder and CTO, also behind these two papers. That was really interesting to read. And again, encouraging you to. I'll put the link to the papers in the comments after, so you can find it there. But I wish you all the best. It's going to be super exciting to follow. Tara, do you want to?
Thank you so much.
Let's shift over,
Yes.
and I'm gonna end this episode the same way I started, with Tara sitting next to me here. Thank you, Majid, for coming and joining us. Hey, welcome back, Tara.
Okay. Yeah, this is good.
Yes,
Okay,
looks great.
perfect. Awesome.
Future, where are we heading?
Yeah, I'm really. It's good.
Yeah, it's good.
I'm really optimistic
Mm.
about the future. So, for example, with our customer, right? So many things were unlocked when this RAM bottleneck was resolved,
Yeah.
right? So imagine how many projects can be done that they are just not in production right now. They're in testing, right? And it's been years, right? It's just like the resources are not sustainable, are not there. Like all of these data centers, right, being built. But imagine like if this is what I think, that it's going towards more of efficiency of using of these resources, the cloud, the RAM infrastructure, the GPU infrastructure. It will unlock so many projects, so many creativity, so many application that enterprises can do, which is going to be great.
Yeah.
That's what I foresee.
Yeah. Well, I agree with that. And it's a fascinating space today, and I really love that we're in 2020. We're seeing from a Capgemini perspective. I'm now reflecting. Many of our clients are moving from pilots and prototypes into production with these systems, and getting attention on some of the layers in the stack that we need to keep improving, and that now with Moorcheh and MemAnto are addressing some of those challenges. That's super exciting to follow, and I'm looking forward to working more with you and tracking your progress as well, and wish you all the best. So
That's
thanks
great.
for coming, Tara and Majid, and with that I am concluding this episode of the Makers, where we had the opportunity to meet the co-founders Tara Khani and Majid Fekri, co-founder and CTO of Moorcheh, and we got a walkthrough of the MemAnto launch. Even we experienced the launch today at the Makers. That's fantastic. So explore that framework and see what you can stitch together with this improved layer of the AI stack. The Makers will be back soon again. We're putting the spotlight on some of the most exciting entrepreneurs and startups in this space. So keep your eye out on the next episode, and hope to see you soon again. So thank you so much for joining, and see you soon again.